Today we are going to start topic number 2, atoms, elements, and compounds. These are the 7 subtopics. We have elements, compounds, and mixtures, atomic structure and periodic table, isotopes, ions and ionic bonds, simple molecules and covalent bonds, giant covalent structures, and metallic bonding. These are the learning objectives that should be covered for each subtopic. Subtopic 2.1 Elements, Compounds, and Mixtures. As we know, the universe is made up of very large number of substances. These substances are called the elements. And each element is composed of its own kind of particles, which are the atoms. So the atoms are the smallest particles of matter. The word atom comes from the Greek word atomos, and atomos means unsplittable. So this means that the atoms cannot be broken down. So if we're going to define the atoms, atoms are the smallest particles of matter that cannot be broken down, or in other words, unsplittable. Example of an element, aluminum, and aluminum element is made up of only aluminum atoms. So each element is composed of one type of atom. Like aluminum element is made up of only aluminum atoms. Copper as an element is made up of only copper atoms. 118 elements have now been identified. 98 elements occur naturally. For example, we have fluorine, we have chlorine, we have gold, we have platinum. So all these are examples of elements that occur naturally. The other 20 elements are made artificially by scientists. For example, curium is an element made by the scientists. Hydrogen atom is the smallest atom. We represent it as a sphere having a diameter of 7 times 10 to the power negative 8 and a mass of 1.67 times 10 to the power negative 24. As we can see in the following table, atoms of different elements have different diameters as well as different masses. Substances have physical properties and chemical properties. What do we mean by a physical property? A property is a characteristic. It's a characteristic of a substance that we can measure. Example of physical properties like the color, the shape, the texture, the melting point, the boiling point, the density. On the other hand, what do we mean by a chemical property? A chemical property is a characteristic or a behavior that is observed when the substance undergoes a chemical reaction. So there should be a chemical reaction. We can measure the physical properties of the substances, then we can classify them according to the properties. For example, we can classify according to the physical properties the elements into metals and nonmetals. If we check this table below, here we have, for example, aluminum. Aluminum is a metal, and this is the density, this is the melting point, this is the boiling point. On the other hand, carbon, it's a nonmetal. Then this is the density. Hydrogen as well is a nonmetal. So here we are classifying the elements into metals and nonmetals according to the differences in their physical properties. Chemists use symbols to label the elements. So the symbols are used to label the elements. The symbol might be one or two or three letters from the name of the element. For example, we have aluminum here. It starts with Al and the symbol is Al. The first letter should be a capital letter. Argon, it starts with A and R and the symbol is Ar. Fluorine symbol is F. Boron is B, bromine is Br. So here all these are examples of elements having symbols related to the name of the element. Symbols also could have no relationship to the name of the element. For example, sodium. Sodium has a symbol Na. Silver has the symbol Ag. The symbol has no relationship to the name of the element. The Na here comes from the Latin name natrium, and the Ag comes from the Latin name argentum. Also, we have here iron. The symbol is Fe, coming from the Latin name ferrum as well. Potassium is a K, coming from the Latin name kalium. When atoms of some elements are joined together in small groups, they form the molecules. So what are the molecules? The molecules are a group of atoms held together. Example, here we have the hydrogen molecule and we have the oxygen molecule. Hydrogen molecule is composed of two hydrogen atoms joined together. Oxygen molecule is composed of two oxygen atoms joined together. As we can see here, we have two hydrogen, two oxygen, so we call these types of molecules diatomic molecules. Di means two. Also, atoms could join in large numbers, like here we have phosphorus P4, which means 4 atoms of phosphorus are joined together, and sulfur S8, we have 8 atoms of sulfur joined together. So we call this type of molecules polyatomic molecules. Poly means many. Are all molecules formed by atoms of the same type joining together? No, the answer is no. Most molecules consist of atoms of different elements. For example, the water molecule. The water molecule is composed of two hydrogen atoms joined with an oxygen atom. Carbon dioxide also is composed of one carbon atom and two oxygen atoms. The compounds. What are the compounds? The compounds are pure substances formed when two or more different elements chemically combine together in a fixed ratio. For example, I have here sodium chloride or table salt. Sodium is composed of two different elements. The first one is sodium, the other one is the chlorine, and they are chemically combined together in a fixed ratio. What do I mean by fixed ratio here? For example, here I have one sodium atom to one chlorine atom. Let's take the other example, ammonia. Ammonia is composed of two different elements, nitrogen and hydrogen. How many nitrogen atoms do we have here? We have only one nitrogen. How many hydrogen atoms do we have here? We have 3 hydrogen. So this is the ratio of the sodium chloride, 1 to 1, and this is the ratio of the ammonia. What do we mean by the formula of a compound? The formula of a compound is made from the symbols of the elements that make up the compound. For example, here we have sodium sulfate. Sodium sulfate is composed of sodium, sulfur, and oxygen. What's the ratio here? The ratio here, I have 2 sodium atoms, I have 1 sulfur atom, and 4 oxygen atoms. So this is the ratio of the atoms, and this is the formula. Mixtures. A mixture contains more than one substance. This substance could be elements and or compounds. Examples of mixtures like the seawater. So this is seawater. Seawater is a mixture of what? Seawater is a mixture of water solution having sodium chloride, oxygen, and carbon dioxide. Air is a mixture. Air is a mixture of oxygen, nitrogen, neon, and carbon dioxide. So it's a mixture of different gases. Also, an alloy is an example of a mixture. For example, here we have brass. Brass is an alloy of copper and zinc. An important note about the mixtures is that the substances in the mixtures are just mixed. What do we mean by they are just mixed? They are just mixed means they are not chemically combined. This is a very important point. So they are just mixed and not chemically combined. There is no chemical reaction. Also, the components in a mixture can be easily separated. How are they separated? By simple physical methods like filtration, crystallization, distillation. These methods will be discussed later in other videos. To learn more about the mixtures, let's discuss this example. Here we have sulfur, which is the yellow powder, and here we have powdered iron, which is dark gray in color, and here we have a mixture of the two elements, iron and sulfur, and here we have a black solid of iron sulfide compound. When we heat a mixture of iron and sulfur together, we get a new substance named iron sulfide. Iron sulfide as a compound has very different properties to the mixture of iron and sulfur. For example here, iron as an element is magnetic, is attracted to the magnet. On the other hand, sulfur powder is not attracted to the magnet. Here, if we have a mixture of iron and sulfur, just a mixture, can we separate the iron from the sulfur? Yes, we can separate the iron from the sulfur. What can we do? We can just use a magnet here. The magnet is used to separate the iron from the sulfur because iron is magnetic, so it is attracted to the magnet, leaving the sulfur powder. And this is a proof that substances in a mixture haven't undergone a chemical reaction. And because they have difference in the physical properties, we can separate them by simple physical methods. While here, regarding the iron sulfide compound, there is no effect of the magnet because it's now a compound with different properties than the components forming the compound. So now let's summarize the differences between mixtures and compounds after studying this example of iron and sulfur. For the mixture, we had iron and sulfur together. For the compound, we had iron sulfide. The first point here regarding if the substance is pure or not. Is it pure substance or not? Regarding the compound, is it a pure substance? Yes, it is a pure substance. Regarding the mixture is not a pure substance because the mixture, as we know, it contains what? It contains two or more substances. On the other hand, regarding the compound is a single substance. The third point is that the composition in a compound is always the same. But for a mixture, the composition can vary. What about the chemical change? In a compound, there is a chemical change. In a mixture, there is no chemical change. It's just mixing substances physically. What about the properties of the individual components? In a compound, the properties are very different in a compound from those of the component elements. What about the mixture? As we said, iron and sulfur still maintain the same physical properties. So the properties of the individual elements are the same. What about the separation techniques? Can we separate the components in a mixture? Yes, the components in a mixture can be separated easily by just simple physical means. On the other hand, regarding the compounds, the components are only separated by chemical reactions.